So the gradient vector, which is a vector whose components are the partial derivatives of a function. Most important things qualitatively to know about it, conceptually, are what are its direction, what are its magnitude, and what relationship does it have to contours, level sets of f. So just to quickly recap, what does the direction of the gradient vector tell us? From a scalar multiplication perspective, the gradient points in the directions. If we draw a line through the gradient vector direction, then that line, when we project it up into three-dimensional space, is going to be the steepest possible line in the tangent plane to the graph of that function at that point. The gradient itself points in only a single direction along that line, and it's the direction along which the function increases the quickest. So the gradient points in the direction of the greatest increase. And actually, as a direct result of that, what relationship does the gradient vector have to contours or level sets of a function? So contours, level sets of a function, are perpendicular to the gradient because, in a way, contours, which represent places where our function's value is constant, which it doesn't change at all, is kind of the opposite, if you like, of the direction along which the function changes the most rapidly, right? So the direction of the most rapid change is plus and minus the gradient vector. And so the direction of no change at all is orthogonal, 90 degrees to that. And the direction of no change at all is the direction that we would walk to go along one of the contours of the function. And finally, what is the magnitude? If I just take the magnitude of a gradient vector,
Take the velocity.
close. So it'd be a velocity if we had a time component, but here we don't have a time component, we have a space component, right? So it's telling me a rate of change of the function in some direction. And given that we know that the direction of the gradient vector is the direction of greatest increase, what is the magnitude? It's a single number.
Ratio, the weight.
Yeah, it'll tell us the rate of greatest increase. So it's a bit like saying the direction of the gradient shows me how to go uphill as quickly as possible on the graph. And then the magnitude tells me how steep that uphill is going to be, right? So the direction of the gradient tells me the direction of greatest increase. The magnitude of the gradient tells me the rate of the greatest increase, the largest value of the directional derivative, which is the value that the directional derivative takes in the gradient vector direction. And so this is a sort of a full introduction to the properties that the gradient vector of a two-variable function can have.